So this question is asking about a basketball player who has jumped off of the court and has reached a maximum height of 120 centimeters. So our first question asks, with what velocity does he or she leave the ground with? And the way that we can solve for that is by using an equation that's given to us. It's a kinematic equation, and it looks like this. It's v squared, the final velocity, squared, is equal to the initial velocity squared plus 2 times the acceleration times the change in y position, or the displacement in the y direction. And so let's look at each part individually. So the final velocity, which will be at this point here, is actually going to be 0, because that is when he's at its maximum height. So that means that this person is not moving for that instant, because it's right at their max height and then they just start to fall back down again. So that's going to be 0. And the initial velocity is actually what we're looking for. And then we have 2 times the acceleration. The acceleration during this time is going to be the acceleration due to gravity, which is negative 9.8 meters per second squared. It's negative because it's pointing in the negative direction, which is downwards. So that's negative 9.8. And then delta y is 120 centimeters, except when we're plugging it into this equation, we need to make sure that it's in meters. So we'll put that into meters, which is 1.2 meters. The way that I did that was I just divided this by 100. Centi means 100, so or hundredth, so it's 120 centimeters is 1.2 meters. Then, as I'm solving for these, 0 squared is just going to be 0. And then v initial squared, we're looking for that. 2 times negative 9.8 times 1.4 is negative 23.52. And when I bring v initial by itself over on this side, that's going to be a negative. And then I have negative 23.52. And so the negatives will cancel, and so I'm left with v initial squared is equal to 23.52. Then to get rid of that square, you square root both sides, and we get v initial is equal to 4.850 meters per second. So that is the speed at which he or she leaves the ground with when they're jumping, in order to get a maximum height of 1.2 meters. Now the next question is, how long do they stay in the air for? So in order to figure that out, we have to understand one thing about this, that this scenario that we first did, where the initial is him leaving the ground, the final is him at the air, that is just 1/2 of the whole scenario, because then the rest of it is him coming back down. So what we can do is we can use this equation, which is another, I'll use a different color here, which is another kinematic equation, and it looks like this. The final velocity is equal to the initial velocity plus the acceleration times the time. This one is useful because it has time in it, which is what we're looking for. So there's 2 ways to do it. I'll do it both ways. The first way is to say that we'll still use half of the scenario, so that means that his final velocity is still going to be 0, just like before, because we're only looking at when he reaches the height, the maximum height. Then his initial velocity is 4.850, and acceleration is still negative 9.8, because it's still being affected by gravity, and we can solve for time there. So when we're doing that, punching that into my calculator, I will do 4 point, so here, let me actually write this out for you. So you need to subtract, so you have negative 4.850 on that side, and negative 9.8 t, and then t will be negative 4.850 divided by negative 9.8. So punching that into the calculator, I get a time of 0.495 seconds. But here's what you need to understand. That's only half of the path. The rest of the path will be him falling back down. And so what we can actually do is just multiply that by 2, and then we get our time to be 0.990 seconds when you multiply that by 2. And that would account for the entire up and then back down path. The other way that you could do it would just be to use the same equation, but instead of saying that the final velocity is 0, you can actually say that the final velocity is negative the initial velocity. And the reason why we can say that is because the speed that you go up with will equal the speed that you come back down with, provided that there's no air resistance. So we can actually make that assumption there as well. So if I'm plugging in all the same things, now we get our speed to be negative 4.85, and if I do the algebra, I get negative 9.7 on this side, and then that's equal to negative 9.8 t. Divide both sides by negative 9.8, and punching that into the calculator, I get a time of 0.990 seconds. So I hope that helped you understand the problem.